So hello everyone. Today we will see class 11 geography NCERT chapter 2, the origin and evolution of the earth. So here I will tell you how to make notes from NCERT, and that too in a pictorial way, and making it easy for you to remember. So so each para I will show you how we are going to make the notes, and we will be able to skip which all para I will be telling you in this video. Okay, let's start. So the first is the chapter 2, origin and evolution of the earth. So this para, it is just an introduction giving it is telling about the sky and numerous questions which the chapter will be able to tell you. So you can skip this para, then we go to the early theories part. See, in the from the early theory part we can make notes. So I have already made the notes. I will show it to you. So this portion mainly tells about the various theories, early theories regarding the origin of Earth. Actually, you can make this into two parts. One is the early theory, and next is the modern theory. So theories, but early theory is telling about the origin of the Earth. Early modern theory is about the origin of the universe itself. So see the notes. So whatever is told in this portion, I have made it into a note. So first is the early theory. There are two theories they are telling. First is the nebula hypothesis. So nebula means this is a nebula actually. Nebula means hydrogen, helium, dust, and it is like like this is a solar nebula. Nebula generally we say like a cloud of gas and dust. That is called nebula. So the nebula hypothesis, it was put forward by Immanuel Kant and it was modified by Laplace in 1796. So the basic idea is this is the sun, and a cloud of material was very near to the sun. It was rotating, and this cloud of material, after a long time, it formed the planet. The planets were formed in this cloud of material. So this was a nebula hypothesis. So this was the first, you can say this is the first nebula hypothesis put forward by Immanuel Kant, which was later modified by Laplace. And then after years, this is happened in 1796. So after so many years, that is around 1950s, this was again modified. So it says like the sun is there, then a solar nebula with hydrogen and helium dust, cloud of gas and dust, solar nebula. Due to the friction and collision, it get converted to a disc-shaped cloud, and planets formed from this cloud based on accretion. So there is not much difference between these two theories. The theory is same. It is telling about kind of nebula, a cloud of material nebula, and this is specifically telling about solar nebula with hydrogen and helium dust, and it got developed into a disk-shaped cloud. From there, cloud is formed. So this is the second modified hypothesis, nebula hypothesis. So this is what is told in the first paragraph. Okay, then. Um, then one more theory, nebula hypothesis, and second theory. So this portion is telling about this theory. It is called the binary theory. So binary means two, right? So the sun is there, and a wandering star coming from somewhere, it approaches the sun. So once this wandering star approaches and leaves, a cigar-shaped material started forming from the sun. So after many years, and it started revolving around the sun. So after many years, this condenses and it formed planets. So this is what binary theory. Binary means like two. Binary means two. No, we can like this is also a sun. This is a star. No, we can say like this is a star. Sun is also a star. So a companion to the sun. So this is the binary theory. A wandering star approaches and cigar-shaped material from the sun forms, and this cigar-shaped material revolves around the sun and it condenses later and it forms the planets. So this is what is told in the first paragraph. So the first origin of the earth para, this is being told about nebula hypothesis and binary theory. We are strictly going via NCERT. Whatever is written in NCERT, we are writing. We are not going in less or more, so that we are sticking to the NCERT. So next portion is the modern theories. This is telling about the modern theories of the origin of universe. Let's see that. So the entire idea of this para, the origin of the universe, it is being contained here. Okay. So the modern theory, all must be knowing Big Bang or expanding universe hypothesis. That is the one theory, and second is the steady state of Hall's concept. So Big Bang or expanding universe hypothesis. So it was put forward in 1920 by Edwin Hubble. No, Edwin Hubble, yes. And there was a question in prelims one year regarding the evidences of Big Bang theory. Okay, so you have to go through that. Okay, then stages in the development of universe. It is telling about this theory is telling about the various stages in development. The stages is like there was a singular atom, and after some time an explosion happens, and it explodes, and expanded particles started drifting away, and it was a huge expansion, and this expansion continues even today. This is what is told. So while the big bang happened, the expansion was very rapid. Then slowly, then after some time it slowed down. So the first 3 minutes after the expansion, the first atom began forming. Then after 3 lakh years, the temperature reduced to 4500 Kelvin, and atomic matter started forming. Then the universe started becoming transparent. So this is a basic idea which is told in this paragraph, and this paragraph is also telling about a balloon experiment. So the experiment is like you are taking a balloon, and you are putting some marks on the balloon. Then you are inflating the balloon. You are putting air inside the balloon. So what happens? The marks which you have created on the balloon, they will be shown drifting away, right? Once you fill the air. So this is what the example is telling. And in that diagram, the marks which you have put, that will also expand, but in reality, the galaxies won't expand. Only galaxies, or you can say, because that mark represent the galaxies. This is what the experiment is. You put the mark on the balloon, and the mark represent galaxies, and once you inflate the balloon, it starts separating. It shows like it was expanding, but in that mark also expands, but in reality that won't happen. That is, galaxies don't expand. So that is the basic concept of this. So see the whole idea of that para from the last page till here. This we have concluded in this much space. So this is the main thing which is being told here. Okay. So next is about the star formation. It is told the star formation. This para we are going to how stars are formed. Yeah, before that, the steady state theory of Hoyle that says like universe is steady. That means universe is roughly the same at any point of time. There is no beginning or no ending. This is what this theory is. Just for your knowledge, keep it. Then the star formation. So the star formation. So this much is the thing. So we are trying to show it pictorially and very easily. So at the beginning of the time, that is the early universe, the matter and energy, it was unevenly distributed. So uneven distribution causes difference in gravitational forces. So this is all connected. So matter energy uneven distribution leads to difference in gravitational forces. So a difference in the gravitational forces causes then matter gets drawn together, and this formed galaxies. As the matter came together, they formed galaxies. So the how this galaxy formed is like it started forming by accumulation of hydrogen gas. So things are coming together, then it started forming a very large cloud, and this large cloud was having hydrogen. Very large cloud is this cloud is called nebula with hydrogen. So after that, after some time, again what happened? So at some point, it started clumping. So localized clumps started forming of stars. See, many atoms started occupying one place, and it formed a clump there. It formed a clump here, like that. So localized clumps started forming, and this became even more larger, and more larger, and finally, then it became stars. This is how stars formed. This is what is being told in this para. Okay. And we know the speed of light is 299,792,458 meter per seconds, or approximately, or 3 lakh kilometer per second. So, and light year is a measure of distance, and you should remember that it is not of time, it's of distance. That is, light travels at the speed of 3 lakh kilometer per second. So the exact value I told, like 299,792,458 meter per second, kilometer per second. Sorry. Okay, consider this: the distance the light will travel in 1 year is taken to be 1 light year, and that equals to 9.46 into 10 raised to 12 kilometer. So in terms of light years, that is And the distance between the sun and earth is 8.31 minutes. So that is it. Next we will see the formation of planets. So starting from here till next page it is there, so we will continue with it. Thank you. So the planet's formation, that is what we are going to discuss. So the formation of planets, the notes is from here. It's from the last page till here it is. So we are going to make a short note on that. So the main content is like planets formation. It's like we already told, stars are localized clumps of gas within a nebula. This is a nebula, and these are the localized clumps of gas or stars, you can see. And due to the gravitational force within, what happens? A core is formed, and a gas dust or a dust cloud, you can see, start rotating around it. And what happened over a period of time, this gas dust, it condenses, and it forms as part of small rounded objects like this, and these small rounded objects are called planetesimals. And these planetesimals, they started pulling more and more such small particles, and pulling together, and due to collision and gravitational force, it will keep attracting all the particles, and this makes it to stick together, and finally it formed the planets. So this is what it is explained in the paras, in that topic, formation of planets. So if you this, you can think in the reverse way also, like the planet is there, then small particles, and they are at a distance, and less number of particles, and they were formed from the gas dust, and this gas dust was formed from the stars. So this is what the idea of that heading. So let's move on to the next. So the next topic is the solar system, from here to here. So we are going to see the notes for that. So that entire concept is explained with this diagram. See, this is our solar system, the sun and 8 planets, and four here and four here. So in between there is something called as asteroid belt, and this belt is between the planets Mars and Jupiter. So the planets which are to the left, or that is more Mercury, Venus, Earth, and Mars, they are called the terrestrial planets or Earth-like planets. They are, because they are made of rocks and metals, and they are solids. They have high densities. And the planets to the right of this asteroid belt, they are called as Jovian or Jupiter-like. So they include Jupiter, Saturn, Uranus, and Neptune. So they have thick atmosphere, and they are mostly made of gases. So what happened? Why this difference between the planet? Why this much difference between these terrestrial and Jovian planets? So the reason is, these planets are solid, and it was too warm for the gases to condense to solid particles. So the terrestrial particles were formed in the close vicinity, of the parent star. They are closer to the sun, right? Hmm? As where it was too warm for the gases to condense to solid particles. So this Jovian planets, they formed at a quite distant location. That is one reason. Then solar winds, due to the solar winds, these are nearby planets. No, they blew off a lot of the atmosphere of the terrestrial planets. The blue of the atmosphere means the primordial atmosphere, the starting of when the planet formed. They had an atmosphere, and that atmosphere was blown off by mostly contained hydrogen, helium gases, and dust, and this was blown off by the solar winds. But this thing does not happen here that much, because it is very far away from the sun. So, and one more reason is, these are smaller planets, and when the solar winds were blowing, these planets were not able to hold, were having less gravity since they are smaller, and they were not able to hold the gases, so the gases were blown off. But in the case of the Jupiter or Jovian like planets, that was not the case. They have good gravity, as the size is large compared to the terrestrial planets. They have good gravity, and they were holding the gases. So this comes under the heading our solar system, and now we will go on to the next, that is the moon. So this topic, and it start from here and it will ends here. So let's see about the moon. So the main idea of the topic is, um, there are two theories of origin of the moon. That is what is being told in that para. So the first theory is like Sir George Darwin's theory that happened in 1838. He produced this theory, and it was telling like both the Earth and Moon were a single rotating body. As time passed, what happens? A dumbbell-shaped extension started forming like this. Okay, and after a long time again, this dumbbell-shaped extension separated and formed the Moon and the Earth. It separated and it formed the Moon, and this became Earth. And due to since this was being cut off from the Earth, there was a depression over this place, and this was filled by the ocean, Pacific Ocean. So this was the theory of Sir George Darwin. So the next theory, which is mostly accepted and important one, that is a big splat or giant impact. So in this theory, what says is this is the Earth shortly after its formation. So what happened? Something or some body which is 3 times the size of Earth came and hit the Earth. So this much size body comes and hit the Earth, collides with the Earth. It blasted a large portion of the Earth into space. So this comes and hit this. A large portion of this goes out, and this large portion started rotating or started orbiting the Earth. And after many years, this formed the present day Moon. So this is a theory, and that is about that topic. So that is over. Then we have the topic called evolution of the Earth, and it includes the subheadings like evolution of lithosphere from here to here, and the evolution of atmosphere and hydrosphere. So these are the topics we are going to cover. So in evolution of lithosphere from here to here, so this is the main idea. So the lithosphere means the upper mantle and crust combined is known as lithosphere. We will study about it in detail in the coming chapters. So, uh, so during the formation of the Earth was in a volatile state. Earth was in a volatile state. So Earth was in a volatile state. Volatile means no, it was not a permanent state. Changes keeps occurring on the Earth, like solar winds were blowing up the gases, and many changes were happening. No, it is not a steady state. Different changes were happening, highly changing. So that is what is meant by this volatile state. During that state, no, what happened is density increased gradually, and as density increased, no, after some time the temperature also started increasing. The temperature rised very high, and this resulted in the separation of internal materials. So there are many internal materials inside the Earth, and the materials started separating based on the density. So how it was separated? It was separated like the heavier materials will go to the center and lighter came to the surface. So likewise, this arrangement was going on. As time passes, what happened? These things solidified, and later it got condensed, and later it formed the crust of the Earth. So this is the general idea which is being told in that para. And you should remember this thing, that if you go from the crust to the core is the innermost part, the density will be increasing towards the core, and that is the core is having the highest density. So we will go to the next heading, that is evolution of atmosphere and hydrosphere. So this topic we will be going to cover. So the basic idea is like they are telling there is a first stage, which we already know, like there will be a primordial atmosphere with mostly of hydrogen and helium, and solar winds started stripping of the atmosphere, and this atmosphere got entirely stripped off, and this is what happened with all terrestrial planets in the first stage. So the second stage comes is like, so the Earth interior was having a lot of gases. So these gases, Earth's interior started releasing these gases, and these gases include water vapor, nitrogen, carbon dioxide, methane, ammonia, and little bit of oxygen. As these gases started coming out from the interior, and this process was called degassing. So the Earth began to cool. Hmm? Earth began to feel more cooler. So, as the earth cooled, this released water vapor got condensed and they gave rains. And when the rain started, the carbon dioxide released from the interior, it started mixed with, it started dissolving in the rainwater. And what happened due to this? Temperature decreased. As temperature decreased, more and more rains happened, and the rainwater, a lot of rainwater we got, and the rainwater started getting collected in the depressions, and they formed the present day oceans. And the oceans, no, they contributed oxygen due to the photosynthesis which is happening in the small plants or in the ocean. And as time passed, oceans were getting more and more oxygen and it became saturated with oxygen. So, what happened? The excess oxygen started spreading into the atmosphere, and the atmosphere started to flood with oxygen. Oxygen began to flood the atmosphere. So, this is being told in the topic evolution of atmosphere and hydrosphere. We will go to the next and last topic in this, and that is origin of life. So, the main basic idea here is there were complex organic molecules which are formed due to some chemical reactions. So let it be, this is be the complex organic molecule. It multiplied, and it multiplied many times and it started getting combined. So this assemblage that they could do after duplicating themselves, and no, they started converting the inanimate matter into living substance. This is what happened. The scientists are telling. So these are the main idea of this. In the textbook, there is a geological time scale. You can see like here. You can just go through it. You can see like from the beginning of the universe, origin of the universe, 13.7 billion years ago to the modern man. Just have a rough idea of this timeline. And that is it for this chapter. Thank you.